All right, so this is a HyperShock. It's a very sparsely filled HyperShock. The way we've done things is we've gone kind of modular with how we do the construction, so it's quick to put together, quick to take apart. So for example, this is a drive module. So we got a motor. We have a magnetic encoder for the motor. It's an AS5147P encoder chip. We have the receiver. It's all RC control. So this is a Spectrum receiver. And then this is our motor controller.
Okay.
It's a Trampa VESC 75300 if you know about VESC brushless motor controllers. And so this thing is something that we can drop in a robot and be good to go. We have a stack of them on the shelf. And so we have a whole bunch of left motors and a whole bunch of right motors. And when you got to throw a robot together, it's really nice and quick. You just drop one in, grab the chain around, add power with two lugs, and you're good to go.
Okay, so these are different for the left and right?
It's the same assembly, left and right, but we...
okay, it just has to be mirrored.
Yeah, for radio signal mixing, we have half of them set up as left sides, and the other half is right sides.
Got it.
So that we can just grab them and throw them in, and we know it's going to work.
Okay. Now, I heard it come up a couple times today, specifically mentioning brushless motors.
Brushless motors.
I know a little about the difference between the types of motors, but what's so special about brushless in terms of an application like this?
All right, so the two kinds of motors you're going to see at BattleBots are brushed or brushless motors. In the past, brushed motors were tried and true. They're very robust, very easy to control. You can use a contactor. You just apply power and it works. But the brushes are a rare item, and they are not particularly efficient, so they get really hot. And you'll see, the teams that still have brushless or brushed motors, they'll have piles of these burnt carcasses of motors because they just go through them so quickly. So in the last couple of years, people have started going to brushless motors, but leveraging a lot of the hobby technology that's been out in recent years, and just trying to make it work because it's pretty darn cheap. Electric longboard electronics have been incredibly cheap recently,
That makes sense.
and that's what a lot of people are running. So we have brushless motors too. A little bit more complex electronically because you have to have a brushless motor controller system because it's a three-phase motor, and we have encoders for position sensing for that low-end torque. Some people use Hall sensors.
Are the encoders external?
Yeah, so it's an external encoder. So it's right here.
Okay.
We have it's a magnetic encoder, so there's a magnet pressed into the axle on the back end, and so the chip is seeing whatever the rotor position is. The biggest challenge that people have had with brushless motors is low end torque. In terms of power and efficiency, brushless is great. But the real Achilles heel has always been that low end torque that brush motors always had. So there's kind of three schools of thought. There's sensorless, which doesn't work. It doesn't work.
I can't imagine that working at all for a BattleBot.
Don't waste your time. There's Hall sensors, which a lot of the hobby motors come with anyway. And then there's magnetic encoders, which we've gone with. A lot of the top tier teams have gone with if they've had the time to put the development effort in, and it works really well. So we get that low end torque that you like with brush motors, but we're getting the efficiency and the power density that you love about brush tools.
Okay, so this unit is here.
So one of these goes here, and one of these goes there for the drive, and then the same parts are just kind of separated for the weapon.
Oh, of
So
course.
let's see if I can
The
find
important
a
thing.
weapon motor.